Welcome back. Now let's really start to learn this formula, this compounding to future value formula, taking into account and keeping an eye towards the fact that there is time value to money. And if you take nothing away from this class, really take that away, that there is value to your time. And so just a quick aside, this is a very simple formula. We're not getting into dynamic rates at all, but always have at the back of your mind that there's uncertainty in the world, things change over time, and this is just a simple formula that can help you guide yourself. So, suppose we have some amount of money today, and we want to know what it's worth in the future. We need 3 pieces of information to learn that. We need to know what the future time horizon we're talking about is, what that period of time is. We need to know the rate at which it's growing, and we need to know what it's worth right now, the present amount. And once we combine all these things, we can learn how much something is worth in the future. So let's explore future value. And to do so, I want to take a step back and define this term interest, which many of you already know, but for those of you who don't, interest is the monetary realization of that concept that there is time value to money. Interest is money paid on debt. So, suppose we have $1,000 and it is growing at a 5% interest rate. In 1 year's time, it will be worth $1,050. 5% of 1,000 is 50, that's the earned interest. So going back to what we learned about that future value formula, here are the 3 elements we need to know. The present amount, $1,000, the time horizon, 1 year, and the interest rate, 5%. And using those, we're able to calculate this future value. Now it gets more complex as we add more elements of time, a longer time horizon. Because suppose we're now in year 2. Well, we want to calculate that $1,000 growing at 5% a year. But in that second year, we've also earned $50 of interest. And that earned $50 is also growing. So in year 1, we have $1,000, 5% interest, growing to $1,050. But in year 2, we're also earning $5,250. Moving forward to year 3, you can see that the amount of interest we're earning on our money is growing over time. We earned $50 in that first year, $5,250 in that second year, and $5,513 in that third year. Let's take a second to unpack what's going on here. In year 1, we have an initial value plus new stuff, $1,000 plus 5% on that $1,000. In year 2, we have everything we earned in year 1, that's $1,000 plus earned interest on that $1,000, and we have new stuff, which is earned interest on that earned interest. What I have here is some math. It's color-coded so you guys can see what's going on. But what you see is in year 2, we're really squaring that interest multiplier, 1.05 squared. And in year 3, we have everything in year 1 plus everything in year 2 plus something new. And again, what we're doing is adding, or I should say multiplying, one more interest term on. And I hope from this color coding you can start to see a pattern develop, which is 1,000 times 1.05 to the first power in year 1, 1,000 times 1.05 to the second power in year 2, and 1,000 times 1.05 to the third power in year 3. And from here, we can build out a formula. How do we go from 3 years to n years? And the formula for future value is the present amount, the present value, in this case $1,000, times the quantity 1 plus the rate, remember the rate in the previous example was 5%, 0.05, raised to the exponent n. And n is the number of years. And for those of you who are less familiar with math, remember that with exponents, anything raised to the 0th power equals 1. So what is future value in year 0? Present value. We haven't earned any interest yet. Anything raised to the 1st power is itself. So what is future value in year 1? Well, it's just present value times this quantity, 1 plus the interest rate. And so on and so forth. Now, there's an important thing to keep in mind here, which is the rate and the time horizon must be measured in the same units. So if R gives us an annual rate, 5% a year, and I give you a time horizon of 18 months, n isn't 18, there are 12 months in a year, n is 1.5. So here I have 2 examples. Take a minute to try them on your own. And you can try them both using that formula we learned, future value equals present value times the quantity 1 plus the rate raised to the time horizon, raised to n. But you can also try it just using that addition we learned to derive the formula. So go ahead and press pause on your computer, try these both ways, and then we'll bring it back as a class. So let's go with this example on the left. Starting with $500 and a 5% interest rate, we want to know the future value after 2 years. Well, we can just plug this into the formula. 500 times the interest rate quantity, 1.05 squared, that's 551.25. But if it's not immediately clear how we got to that number, we can also calculate it using simple addition. So we can calculate 5% on $500, that's 25. We can also calculate 5% on that earned interest amount, $525, that's 26.25, and then we can add it all together. So our initial amount, our first year of earned interest, and our second year of earned interest, and that's going to get the same amount that we got from the formula. Note how 1.05 in this case is just 1 plus 0.05. So here we're multiplying by 0.05, and the 500 is just itself. In this second example, simple addition and the formula are even more obviously the same because we don't have to raise to an exponent. Raising to just 1 year, 1.08 is going to be itself. So $1,500 times 8% interest, we're going to earn $120 of interest in that first year. That's $1,620. Or we can just go ahead and multiply it all out, that quantity 1 plus the rate, and get 1620. So it's important to note that little changes in the interest rate are going to make a big difference. And this is important for saving money, for earning money, but it's also important in the other direction if we are accruing debt. And so in our next unit, when we talk about credit cards, we're going to see that small changes in your credit card rate are going to make a big difference in how much you owe. And certainly, the higher the interest rate, the faster that total amount grows. In this example on the right, we see difference between 5 and 10% rates. So suppose we have $1,000. In just 3 years, we're going to see a massive difference. So before our next little lecture nugget, why don't you guys take a minute and play around with compound interest on your own? And think about the own money you've saved up or the money you've accrued as debt and see how they're going to add up over time. I've got a link here. You can follow the link. I can also drop it into the YouTube notes so you guys can play around with it from your computer screen.